this was a video that, one second, let me make sure I got to. So this was a video that, or this was a book, The Myth of the Objective, that some machine learning folks recommended to me recently. And so I wanted to watch the video first. I like to, if there's a video, it's always good to watch a video before you buy. And so great. This is the, if you're kind of seeing this for the first time, this is a coding and live, so a live coding, live watching, whatever we feel like doing, a live paper reading, live paper watching, or conference video or conference talk watching, whatever, on Tuesdays and Thursdays at 11 a.m. Eastern time. Let's just jump right in. And sorry for if you hear my audio might be a bit off today because I'm traveling. This is not my apartment, and so I don't have any of my gear. I'm just using the phone. I'm sorry, the laptop audio. Let's get it going.
Okay, thank you. Just a small correction is I'm actually computer science, not EE, so I don't actually know about EE, but I'm from the Department of EECS, so it's just a little confusing. So this, what I'm about to tell you today is from this book. It's based on this book, which is out now, called Why Greatness Cannot Be Planned. I'm a computer scientist, and I study artificial intelligence and machine learning. So you'll see a connection there. So here's just the general summary of what I'm going to be talking about. We were researching artificial intelligence. That's basically what I usually do. But this sentence sounds really strange, but this is true. We ran into a problem with objectives. This is a very general statement. But indeed, we saw a flaw with this very general thing that everybody does, which is setting objectives. And therefore, the consequences of this discovery, which I'm going to show you, they extended way beyond just artificial intelligence to things like creativity, innovation, and collaboration. Let me give you the short summary, but obviously there's a lot of subtleties here. Setting an objective can block its own achievement. But furthermore, it can be an obstacle to creativity and innovation in general, even if you don't have any particular destination in mind. And without and this goes furthermore, it tells us that without protection of individuals.
Hey, so if you just joined, thanks for joining. So so yeah, this is a thing that I do. I'm trying to keep regularly. I do every Tuesdays and Fridays at 11 Eastern, where I go over a paper or watch a paper video or a conference video, maybe do a bit of live coding. This is there's a book by Kenneth Stanley called Why Greatness Cannot Be Planned, The Myth of the Objective. And it was hardly recommended to me recently, so I figured, all right, well, let's just watch the video and see if it seems to be worth a read. Sorry if the volume sounds, the sound sounds tinny. I don't have all my gear with me because I'm traveling.
Individual autonomy, collaboration can become dangerously objective, and I'm going to show you that as well. The reason that this is really relevant and that we decided to write a book is because so much of our society is driven by objectives. The gatekeepers are asking for objectives to justify almost any endeavor, including a lot of people here. And if there is some kind of flaw with objective thinking, then this should be really concerning to us, especially as it relates to creative and innovative endeavors. So here's what I'm going to do. I'm going to start with the artificial intelligence, and then I'm going to segue into the broad implications. So now this is going to seem like I'm going way off on another tangent. But if you just bear with me, you'll see how this connects in. And in fact, this was as surprising to me as it is to you that this has anything to do with a general statement about setting objectives. Because when we first launched this experiment called PickBreeder, we weren't trying to make any statements about setting objectives. This was an experiment with an entirely different motivation. But what we learned from it was really deep and really interesting and unexpected. So it's kind of serendipitous. So if you just bear with me, I'll kind of give you the sense of what this experiment was about and how it led to this realization. We put this website on the internet called PickBreeder to allow people to, no surprise, breed pictures. And that really just means like the way you might breed, horses or breed dogs. Like you have a population and you're breeding them. So like if you went to PickBreeder and you told it you want to start from scratch, you'd see an interface like the one you see in front of you right now. There's 15 images in front of you, and each one of those can be thought of as an individual in a population, like one of your horses. And I can breed them just like I might breed animals, but I'll just have a single parent just for simplicity in the example. So like I might say, well, this one of the 15 is kind of interesting. Let's see what happens if it has children. Okay, so there its children. And one of its children looks particularly different, so let's choose that one and say, okay, what if it has children, and so on. Now, if you think about this very simple toy, and sometimes things like this are called evolutionary art, where do you think this could go? It's kind of interesting to speculate. What do you think people would find? Like, say you did several dozen generations of this, you'd get tired pretty quickly. But what kind of things do you think you could find? And the answer, we didn't know for sure what would happen. But what we did think would be interesting would be to unleash hundreds of people around the world into the search space and see what happens.
So usually when the videos or the paper videos, the things that I look at in this stream, I tend to be familiar with. This is completely off the wall for me. I don't know what he's talking about. So this idea that greatness cannot be, the myth of the objective function, or why the objective function can get in the way, I relate to that, but I don't know where he's going with this. Just in case anybody was wondering, this is new to me.
And the answer was really astonishing, actually, for us. It's not really what you might expect. And I'll give you a little sampling of the kind of things that people found.
Whoa.
And this was a big surprise. First I should emphasize that this is not the work of artists. This is not retouched in any way. This is the result of breeding blobs, and this is some of the things that the users were able to find. You can see some remarkable resemblance to kind of everyday things, like there's a skull and a butterfly, and this seems to be Jupiter with its red spot there. And so actually the story of why and how this became possible is really interesting in its own right. And that's what I'm going to get into a little bit. But before I do that, I just want to give you one other little technical bit that's going on under the hood so you can really understand and appreciate how interesting the story ultimately is. And that is that there's one thing that you can do that I didn't mention yet, which is called branching. And what's going on is that if I was playing this game and I found something that I liked, I'm allowed to press a publish button, and that publish button will send it back to the website for PickBreeder, and then it goes into the PickBreeder database, and now anybody who ever visits again can see what I discovered. And what they're allowed to do is called branch, which means they can take the thing that I personally bred, and then they can decide to breed it further. So in some way, this is like kind of standing on the shoulders of your predecessors, so extending on their invention. And so, like, for example, this face was on PickBreeder. Somebody published it. And I could come in and say I want to branch from it. And then what would happen is I get an interface that looks like this. And it becomes apparent, and the usual game can be played. Oh. So now I can say, okay, I'm going to, let's say I like this one. I don't know, it has a big mouth, so we'll make it apparent.
See, what I'm wondering here is, like, what's the neighborhood function here? Like, how is variation added to this to generate these outcomes? It has to be according to some sort of aesthetic principles. It's not just randomly adding noise to pixels. Be interesting to know how that works.
And then we can keep on iterating like that as before. And then I could publish when I find something interesting, and that'll go back to the site. So the effect of this is that what's going on under the hood is that you're getting what biologists might call phylogenies, large branching, diverging phylogenies that look kind of like this. This is a small subphylogeny. There's about 10,000 images on the site, so this is just a small subset. But you see what's happening over time as people branch upon branch upon branch, and that's what's leading to this stuff. So it's coming from branches upon branches. But it's interesting to understand why these discoveries are possible. Because if you really think about it, these are really impressive discoveries when you think about their humble beginnings with just some really random blobs. And I want to look at the question.
So, for example, symmetry certainly seems to be an aesthetic principle that's preserved in a lot of these, but not always.
Of how are people discovering these things? Now, actually, there's kind of two camps of thought, and I know this because I've spoken about this so much. One view is sort of like compatible with what I've been saying, which is, yeah, I'm really impressed. Like, explain to me how this is happening. I don't really understand how this could be possible. But there's another view I want to address, which I'm sure some of you hold, which is, now hold on a second. You're telling me I should be impressed here, but I'm not really sure I should be impressed. Because after all, let's, for example, think about this, like this teapot here. What if I wanted to create a teapot? So this is where we connect into objective. So let's make it an objective, starting with just some blobs, but I want to get a teapot. So I'll make it my objective, and what I'll say is, okay, given it's true that most of the blobs don't look like teapots at the beginning, of course, but I'll choose the one that looks the most like a teapot. And then in the next generation, I'll choose the one that looks the most like a teapot. So basically, I'm measuring my choices against my objective. I'm making incremental improvements measured against the objective. Won't I eventually inevitably get what I want, my objective? So in that sense, why should I be impressed here? Isn't this all just inevitable, what you would expect? And if that were true, then I would agree that this isn't really that interesting. But what's fascinating is that that is not true. It does not work that way. In fact, if you came in with that attitude, you'd almost surely fail.
Wait, so to rephrase, if somebody came in with the objective of getting this teapot, then they wouldn't succeed in getting that teapot. Is that the idea?
And that's why actually a lot of people find this game pretty frustrating.
Can I try something on you?
Yeah, sure.
Isn't this just incestuous evolution? What you're just saying, from a biological point of view, you'd expect it not to go down a projected path. You'd expect a surprise. But you're taking a child, breeding it, and then when it matures, you're putting it back in as a parent.
Mm-hmm.
About.
Yeah, so actually, let me address a little bit the intuitions about why this wouldn't work. It doesn't work. We know this empirically. You can't play it this way. But why not? Well, I mean, think about it. I mean, this is why is any problem hard? The reason problems are hard is because we don't know how to get to the solution, which means, in effect, we don't know what the stepping stones are that lead to that solution. In any complex search space of possibilities, it's always going to be the case that we don't know the intermediate stepping stones that lead to our objective. Because, after all, that's almost by definition, because if we did know the stepping stones, then we just go there. Mm-hmm. So this is the hard problems, the interesting problems are always the ones where we don't know what the stepping stones are. And, of course, in a space like this, you can tell just intuitively. I mean, I haven't given you all the under-the-hood, artificial DNA and stuff like that, because I don't have all the time. But you can tell intuitively that this is a complex search space. It's not simple. So it's not like the things that lead to teapots are all just little mini baby teapots. It's going to be something different. And in that sense, you can't get to these places by trying to get to them. So that's pretty puzzling, because when you look at this, then this really leads to a really deep question, which is then how the heck are people getting to these places? Because they're clearly getting there consistently, but I'm telling you, you can't get there by actually trying. So then what is the key to getting to one of these interesting kinds of discoveries? And I'm going to use the story of this car as a kind of an allegory for how this happens in general. And the reason that I can use this story is because I happen to be the guy who discovered the car. So I know exactly what happened along this path. And this was a really kind of important moment for me when I discovered this car, because it was the very strange experience of discovering this car that led me to first start having doubts about the objective approach in PickBreeder.
All right, so he's going to tell a story about a car. If you're just coming in, this is a talk by Kenneth Stanley about a book that he wrote about calling into question the use of objective functions, which, of course, if you work in machine learning, are things that we do a lot, or we work with a lot of, things that we use a lot. And so, so this is, the book came highly recommended, so I figured we'd watch the video today, see if the book is worth a buy.
Which led to everything that I'm telling you today in the book that we have.
So what he's doing here is he's introduced a set of an algorithm that iterates through a space of it's like I guess you'd call it like a genetic algorithm that is developing images, and these images, there's a little bit of human feedback about what people kind of like and what they don't like. If you like something, other people can branch off of it. So you get things that coalesce into things that humans like things like this car. And he's arguing that if you were to say create an objective function that were to say I want to get a car, so just develop, tell the algorithm to optimize towards a car, that it wouldn't work. And I guess he's going to explain why with this story of the car.
So this, in some ways, strangely enough, evolving this car was kind of an epiphany, or a turning point in my life. So here's the story of the car. And the most important part of the story is just that I wasn't looking for a car. But what I did see was there was this thing that looks like, to me, an alien face. Actually, it looks like E.T., I think. And someone else had evolved that. I never would have evolved it. I don't know how to evolve it, but someone else did, so it was just on the site already. Someone had published it. And I was thinking to myself, as you might think, well, this looks kind of cool because, like, if I chose this, I might get all these different aliens. It looks kind of promising in that sense to me, like a good parent for having lots of alien faces. So that's the road I went down. But then something happened, and this is the kind of moment of epiphany, which is that these eyes started to descend over the course of the breeding process. Ever so slightly, they started to descend. And I realized, there was a moment where I just realized, hey, this is starting to look like a car. And when I realized that, I suddenly realized I can get to a car. And that was the moment when it became possible. And then I was able to steer the process, with no pun intended, towards a car. And so then I got a car. And this story is really strange. I want to emphasize how strange it is, because you've got to think about all of the factors that had to come together for me to discover this car. Let me just lay it out for you. First, someone had to do something that I never would have done, because I never would have evolved that alien face. And then second, I had to not be trying to do what I ultimately did. Because, after all, if I was looking for a car, I would not have started with this, because that is not a car in my view. So it sounds kind of like, okay, this is a very sort of unusual set of circumstances that might be viewed as a lucky coincidence, even winning the pick breeder lottery. I mean, with all these extremely unlikely events kind of coming together to allow this discovery to happen. But here's the amazing thing. This is not a coincidence. It's not an exception. This is the rule. Almost every top image, all the interesting images on the site, has exactly that story. That's always the way that things are found. So, like, in other words, the stepping stones, they almost never resemble the final product. So let me just give you a couple examples here. Like, somebody evolved or bred this thing, and I call this an egg with a hat. That's what I think it looks like. Okay, so it is inconceivable that that person who discovered the egg with the hat said, aha, finally we can get teapots. There's no way that was happening. And similarly, the person who eventually branched from here and got to a teapot, they didn't start out saying, finally there's an egg with a hat, that's just what I've been needing to get my teapot. It's inconceivable that that's happening. Or a dish that led to a skull, or this looks like a letter G that led to Jupiter. It's always the case that the stepping stones don't resemble the final product. So it leads to this really counterintuitive moral, which is you can't find things by not looking. You can only find things by not looking for them. And this is sort of a rule. And so this is an interesting insight about this site. But does it apply outside of PickBreeder? Is there something special? And of course, I'm going to try to claim to you that this is actually a general insight about creativity and discovery. And it should start to be ringing alarm bells, because we run our society as if this was not true. We are constantly setting objectives. How are we going to get to the skulls and the butterflies of our particular domain of interest if we run our society through objectives?
Can I just give you another poke over here on the left?
Yes.
What you just described is the history of science. You know, people
Yes.
have been wandering around and just discovered stuff.
Yes.
And they didn't even construct an experiment to discover what they found. They constructed it to find something else. Mm-hmm. So there is a very strong corollary here with history.
Yes, thank you for bringing that up. Actually, I was going to connect this to the history of science a little bit later, so that's a very astute observation. In fact, there's several processes that work like this. Human innovation is one of them, and there's a few others that I'm going to show you. Let me just show you a little more evidence, just to drive the point home. So here's a weird experiment that we did later. We said, okay, we know for a fact that the skull and the butterfly, just as examples, have been discovered. There's no controversy about this. Obviously, somebody discovered these. They exist. So they exist in the space of possibilities, clearly. not only do they exist in the space of possibilities, but they seem to be relatively easy to find if you look at how much effort went into finding them. There were only 74 selection steps in the history that led to the skull, 90 in the history of the butterfly. So in terms of like, machine learning or computational search, this is peanuts. I mean, we're talking about millions of iterations in modern algorithms. These are like dozens just to find these. So you might think, well, these can't be that hard to find. And they must be sort of like really close by in the search space to any kind of starting position. But actually, so we said, okay, let's see about that. Let's test that. Let's run an algorithm which basically plays PickBreeder automatically, but always picks the image that's closest to our target or our objective. So we make it into an objective-based search, and we try to rediscover things that were already discovered. This should be easy, right? But it turns out, if you look at these, each one of these images is the result of, and get this, a 30,000 generation attempt to reproduce that image. Remember, these only took a few dozen, but we gave it, big computation because we're in the era of big computation. So we gave it 30,000 generations, and every time it's a miserable failure as an objective. Now, if this was just, some normal machine learning benchmark, you might say, well, the problem is that for some reason, this is too hard to discover these things, or the algorithm is not equipped, or something like that. But that can't be the explanation here, because we know these were discovered, and with not very much effort, in fact. The explanation here is that you can't discover these things by looking for them. They can only be discovered by not looking for them. Why would that be? Well, it goes back to this notion of deception. Deception is sort of a notion in search. When people talk about search and optimization, it's a pretty familiar notion. But what this is saying is that this idea of deception is far more pathological than it's often given credit. In other words, what deception means is that you can appear to be going down the wrong path, but you're actually exactly on the road you should be on, or vice versa. You can appear to be way off the road. You can appear to be on the correct road, but you could be running towards a dead end. People know these things as local optima. But it's so severe. I mean, look at this is why we can't get to the skull by trying. Because look, like this crescent was something we would throw away if you said, I want a skull. You say, well, this is not a skull. It's not anything related to a skull. Or this donut, that's not a skull. Every step along the way is deceptive. Now, it's often true that in hindsight we can make a connection. Like we can connect the eyes of the alien face to the wheels of the car. But going forward, there's almost no hope that that kind of very abstract or subtle connection can be made. And so deception is the reason that you can't find things by looking for them. So one thing we did, like in the world of artificial intelligence and machine learning, is we were thinking these implications are kind of disturbing, because like even in machine learning, like almost every experiment is run through what's called an objective function. Everything I've been taught was that you set an objective and then you sort of follow a gradient towards that objective. But the world of PickBreeder works exactly in the opposite way. You have to not be following the gradient of the objective. So we said, what if we actually just started to actually create algorithms that respect this principle, this non-objective principle? And we created an algorithm along those lines called Novelty Search. So what is going on in PickBreeder? One interpretation of it is that it's a collector. It's not a finder, it's a collector. Basically, it collects stepping stones. And the reason that that's powerful is because the more stepping stones you have, the more stepping stones you can get to. Now, if your next question is, but where are we trying to go, then you're missing the point. That is the point. We're not trying to go anywhere in particular. We're just trying to amplify our ability to get everywhere. And so we said, we can make algorithms like this. We don't have to have objectives driving algorithms. So we created an algorithm which basically just says, try to generate completely new behaviors, no objective in mind, and just proliferate all the jumping off points that you can. And there were...
So somebody still has to go in there and define like the physics of the space and whatever a jumping off point is.
There was a succession of interesting results that resulted from this algorithm called Novelty Search over the last few years, which all sort of showed the same thing, which is that in many domains, I'm not going to say all, but many, it is the case that you will get a better solution and find a solution faster by not trying to solve the problem. In other words, by just trying to generate novelty. And I'm just going to show you one example of this, just for illustration. And this is a biped walking domain. These bipeds were told, we wanted them to be able to walk. In the case on your left, which says fitness best, we will see the best product of traditional objective-based optimization. We said optimize the distance you can walk. And that was sort of given to the learning algorithm and said, come on, try to make the best walker you can. In the case on the right, we said, just generate novel behaviors, and if they're really novel, then explore them further and try to generate more novel behaviors. And what you can see is the best we got from that is far superior to the best we got from trying to optimize the behavior. So this counterintuitive principle raises its head again, but now in a very different domain from the domain of pictures. And that's sort of important because it shows you that this is a general principle. Yeah, I mean, and he had a bad night last night too. So you may say, whenever people see results like this, it's always they're scratching their head first. They say, this is kind of disturbing and counterintuitive, and there's got to be a flaw here. But what you have to remember, and it's always sort of the answer, is the problem is deception. The stepping stones to walking may not look like walking. What are you going to do then? You know, the thing is, like, one stepping stone to walking is to learn the principle of oscillation. That's part of walking.
So I guess like one way I would think about this is that it's like there is the objective function is penalizing loss between some ideal and the current state of the search algorithm, and it just might be that sometimes you have to endure a lot of loss before you ultimately get to a place of less loss. In other words, that so that's what he think. That's what he said. Stepping stones to walking may not look like a walking. So you might be doing a lot of behaviors that a normal objective function would penalize, while those things might based on this idea of deception might end up looking like might get you to a better point. The issue is that this is kind of, you know, here you basically had to simulate many different behaviors, and you kind of pick one. While here you just, or rather you have different, what he's got phylogenies. You have different paths down, many different paths down the tree of behaviors. While here you just kind of have one. So I'm not sure if he's addressing the cost of doing it this way. But.
Right? And so what if you learn to oscillate but you fall on your face? I mean, from an objective optimization standpoint, you've made absolutely zero progress towards maximizing the amount you've walked. And yet it could have been the fundamental discovery that leads to the principle for very robust walking. And this is why objective optimization will not be the best way to generate walking. So the implications seem to us profound. We started putting these things together. And I apologize, this sounds like something out of a fortune cookie. The path to success is through not trying to succeed. To achieve our highest goals, we must be willing to abandon them. Or, connecting to collaboration, it is in your interest that others do not follow the path that you think is right, like the person who bred that alien face before me, which I never would have done, because they will lead the stepping stones to your greatest discoveries, like when I discovered the car. And when we're looking at this, we're like, you know, wait a second. This is actually not about computer science. I could tell this to anybody. And this would be a deep conversation. In fact, like, this is something that dawned on me over years, because initially I was speaking about this a lot, as you can imagine, at like AI-related conferences or computer science conferences. And really in an algorithmic context, I'd be talking about these results. But more and more it dawned on me that people really wanted to talk about this stuff in like a human perspective. They're saying, what does this mean in general, you know, for objective-driven discovery? You know, when you send a proposal over to the National Science Foundation and you say, here's my project and here's my objective, what is that doing to the way that the process of discovery works in general across all of science? The fact that we tend to guard our gates with objectives. You don't have an objective, so how can we give you any funding? I mean, what are you trying?
Well, if you have 1 million people to give funding to, then, and one of them will kind of discover something interesting that you don't know about, you can't predict, then great. But you can only give out so much money. That's what I'm missing here. Is you get, this assumes that you have the budget to develop many divergent paths.
Trying to do, it's completely unprincipled. But if it's true that often there are things that we cannot find if we do have an objective, then we're in trouble. So So here's some implications for collaboration. You know, because what it kind of says is that without care, and this reflects some of the things that have been said earlier in this conference, but without care, collaboration can lead to convergence and consensus of a very, very pathological type. Because the problem that happens when you're collaborating with people in a consensus-driven framework, which is like, you know, the way many institutions are run, if you have a panel of experts, you're moving towards consensus. This is true. It's going to prune out the stepping stones. You're going to lose all your diversity. I mean, could you imagine if, when I branched from the alien face, if there were a panel of pick breeder experts, like the luminaries of pick breeder, all got together and said, well, hold on a second, like, is this really justified? You're branching from an alien face here? No, and people need the ability to follow their radical paths to their bitter ends so that we can see where those stepping stones might lead. Otherwise, we get this mediocre washout effect. Compromise for all, but preference of none. And I can show you a great example of that. Coincidentally, and this is really cool that this happened at about the same time, this project called the Living Image Project was started at about the same time as PickBreeder. And it was really nice because it happens to have under the hood like the same mechanics as PickBreeder. Same kind of genetic encoding, artificial genetic encoding, same kind of search operators, except that instead of a branching operation, the way that it worked was it was based on voting. So it would show you some images just like you see in PickBreeder, but you would vote. And over like a week, it would collect hundreds of votes from a palette of options. And then it would say, okay, whichever option got the most votes, that will be the parent of the next generation. And after 25,000 votes were cast, an enormous amount of human effort, these are the 9 highest rated images of all time that were generated by the Living Image Project. And you can contrast that with the PickBreeder. This is probably a lot more effort that was put into this project than PickBreeder. And yet look at how much more stunted these results are. This is the result of convergent consensus.
That's just stark. Most scientific funding decisions are made this way. That's kind of depressing.
And it's just so stark. It's nice to show this through images because it makes it so explicit. You know, we can talk about it in the abstract, but here it is in front of you. Is this the world that you want to create or live in? And you know, this is the world that this is just again to reiterate this point. This is how science is basically driven. You know, we base science funding decisions on convergent consensus. What is it doing? What would the world look like if we were doing things this way?
So on your left here, back left.
Yeah.
This is really exciting, and you know, I'm shocked also. But there's a meta point here which I find also interesting, and maybe you might want to comment on. Maybe a meta point that might be right or might be not. You didn't set out to discover this.
No.
Right.
No, we did not.
So the meta point is that this was discovered by not setting out to discover it.
That is a great point. I mean, actually, to actually.
There's actually something that kind of occurred to me as I was watching it. I was like, is this guy turned his like. It's almost like he turned his failures in research because he was obviously trying to do something else, and kind of it wasn't working, and he's trying to figure out why, and came up with some insight, and then turned that into new research. That's kind of fascinating.
Elaborate on that a little bit, just to make it even more ironic. I actually proposed PickBreeder to the National Science Foundation before we'd made it, and it was severely rejected. And the explanation from the summary of the panel's feelings was that it's entirely unclear what your objective is here. No, it's not clear what you're trying to accomplish. They said nothing good will come of this. And again, this happened before any of this theory had arisen. So
trouble is,
Lynn.
NSF is peer-reviewed. It's a group. It's consensus.
Yes, it's
exactly
convergent
not what you
consensus.
want.
Yes. Yeah. I mean, this is my revenge.
Right. Immediately next to Lynn.
Yeah.
So if I were to think about this mathematically, I might think that if I were in the area of the local maximum that I'm interested in, I want to use the gradient method. But if I'm anywhere farther away from it, there are going to be lots of local maxima, and I'm going to approach the maximum I want only by using a genetic algorithm, right? The gradient approach won't get me there.
Yeah, so I mean, I think the spirit of that is correct. I would agree, except that it's not that it's a genetic algorithm. I mean, because a genetic algorithm can be run objectively, and in fact, in the world of genetic algorithms, even they are usually objectively driven. Like you give it something we call a fitness function, and then that is basically a measure of how far you are from your objective, and that's the score we give an individual. So there's like really, before novelty search, there's very few search techniques that existed that sort of captured the spirit of this intuition. But in reality, we can sort of apply this intuition to almost any technique, including a genetic algorithm, because we can just reward something other than objective performance, like novelty. Or like in PickBreeder, I'd argue what's being rewarded is what we'd call interestingness, but that's very hard to formalize. I just wanted to highlight here that one of the lessons here is how essential it is to protect individual autonomy in creative endeavors. I'm obviously not saying that this applies to everything. Like, I'd be a kook if I got up here and told you drop all your objectives. You know, no objectives anymore in corporate America. That would be crazy. But when you're trying to foster innovation, it's in those pockets where this becomes a really dangerous problem. And in those places, this shows you very starkly why it's so important to protect individual autonomy. Because the reason we're getting to these places is because people, once they branch, are completely isolated from everyone else. No one can interfere with me while I'm on my branch. I go wherever that may lead me. And that's why we get to see all of these radical stepping stones.
I guess this is why we have like the tenure system, right? So we can protect the ability for people to go in just weird directions. And one of the things I've noticed recently, kind of in terms of research within industry, is that you're very much objective driven, and that often leads to suboptimal outcomes.
Accumulating. If we didn't do that, we live in a world like this.
Before you move on, Ken,
yeah.
we have a question up
Oh,
front.
sorry.
Yeah. What do you think Edison would have said?
What would Edison have said? Could you tell me why, or some context?
Kind of a purposeful, objective guy. You know, I can see you right now because of him.
Yeah.
So.
Yeah. So I think, you know, there are a lot of people who have set out and done something amazing. I mean, Edison's an example. Who you may think are counterexamples, or maybe they even somewhat, you know, relieve the anxiety I'm giving you and say, this guy's exaggerating how bad the situation is here, because look at all these achievers. But my interpretation of those things is that what's actually happening is that these visionaries are people who realize that the stepping stones have been laid. It's not that they see several stepping stones into the future like some omnipotent visionary and can see the path. It's that they realize that we're just one stepping stone away because of things that were done by their predecessors. So, you know, things like it took vacuum tubes to build the first computer. But the people who were designing vacuum tubes were not thinking about computers. If you had told those people that they need to work on making a computer, like go back, you know, to the 1800s and say, you're wasting time with vacuum tubes, build a computer, this is a much cooler idea. We would have no vacuum tubes and no computers because they were working on the very stepping stone that we needed. But there was a time where the vacuum tubes were available and the stepping stones had been created. And so that created that possibility, and someone was standing on that stepping stone at that time and realized it's just a little bit of a step from there to computation. And so I think, no, the issue is that somebody like Edison is looking at what has been created.
It also implies like the future, especially of innovation, is impossible to predict, right? Because if innovation happens according to this process, then how could you predict it?
In the immediate past, and seeing that possibility has been created that's just a stepping stone away that we didn't realize before was.
All of a sudden, we've got a bunch of questions, so let's try to get through them all. Mark.
Okay.
So that was a just breathtakingly brilliant presentation. Thank you. And it actually correlates enormously with my own personal experience. I was asked to set up an innovation center at a big healthcare system, and the person, our CEO, set it up, had the wisdom to say, if I know what this is going to be, it's not going to be very innovative. And that the three most important things that we've accomplished in the last 3-4 years have none of them were planned, and all of them just happened actually because of personal relationships. And and the other observation you're thinking about, look at the interesting images you got on 74 steps as opposed to 26,000 steps. It sort of validates the principle that all great ideas are simple. And it's really just terrific. Thank you.
Yeah, I mean,
Okay.
there's a million examples like this, and I hate to say something so cliche, but if you read the book, you can find like a lot of them. We collected tons of them, like these kind of serendipitous discoveries, which happen to be more the rule than the exception when it's really something exciting.
Okay, we will get to all the folks who have their hands raised. There's a couple in the...
Okay.
Tim.
Here on your left.
Okay.
So,
yeah.
awesome talk. I love the idea. But my question is, how do you identify a stepping stone? What is a stepping stone for you? How do you quantify that? And, you know, all those people now who like to implement that in their firms, you know, how do we know what's a stepping stone?
Yeah, let me say a couple things about that. A stepping stone is something that can lead somewhere interesting. So it's something that creates potential. And I think that we have become afraid to acknowledge that those with expertise have the ability to identify things that are interesting. You know, the way we think about it is that we need to subject you to some kind of accountability and assessment to make sure that you're not wrong if we go down this path. So we need some kind of objective metric to say, are you moving in the right direction?
You know, it also makes me think how, you know, the advice, you know, the other days somebody was saying like, what are my plans 5 years out, 10 years out, right? And, you know, so this is some kind of, it's very objective driven, right? And I realized a while back, the whole kind of Chinese five-year plan thing doesn't really work for me. I just kind of just work by following my nose. And yeah, it's interesting how one might struggle, might turn this into a self-help book in the sense of like, just focus on the stepping stone, I suppose. I don't know. Interesting.
But the problem is that the stepping stones are the things that we recognize not because they are objectively superior, but because they have some kind of intrinsic potential. And that intrinsic...
So I find myself thinking like, all right, well, let's imagine that here is the objective, here's the maxima, right? Here's the best source of reward. And then the agent is here and they're searching, trying to find it. And in the middle, there's a wall, right? So all the other agents who are kind of minimizing distance hit this wall, while a divergent agent might just start taking random walks and eventually land on the other side of the wall. But it's a very expensive walk, and it makes me think like, well, could one now just apply principles to this search space? Like, if an agent understood how walls worked and that they are finite on one side or the other, and said like, well, I need to get to the other side of this wall, why don't I just pick a direction and walk and see where the wall ends and see if I can't get around? So that kind of mechanistic knowledge of the world seems to be missing from this conversation. I'd like to see how that factors in.
Potential is very difficult to formalize, but we see that humans are particularly good at identifying it. So in PickBreeder, the people who are finding the interesting images are playing exactly that game. You know, they see something that they think is interesting, like the egg with the hat, and they publish that because they think it has potential, it's interesting, it's going to lead to other interesting things. We can't exactly say where it's going to lead. And we can see this across, I think, many domains where experts often have these kinds of intuitions. Novelty Search, which is this algorithm we created to try to capture this idea, it just says novelty is the proxy. So novelty is like a proxy for interestingness. If you can generate something that's genuinely novel, then that probably will lead to more things that are novel as a stepping stone. But it's not the be-all and end-all of what identifies a good stepping stone. What identifies a good stepping stone is ultimately something subjective, and that's why we have so much discomfort with it, and that's why we tend to align our institutions away from that, because we don't like subjectivity. But we're going to have to accept subjectivity if we're going to embrace this principle or the objective paradox.
Okay, Eric?
Let's get more slides. Where's questions come from?
A couple of, maybe they're questions and observations. I have always wondered why it is that the most creative artists seem to be the most mentally deranged.
What?
And you may have helped illuminate that.
Right.
Also, an observation that meshes with comments that were made earlier about science. The most profound discoveries in science are often made by outsiders. The fellow who came up with the tectonic theory of the way geology works was a complete outsider. He was an amateur and was roundly derided by the experts.
Yeah.
But he was able to, well, perhaps step on stepping stones and build to the next stage in a way that the experts couldn't. Finally, moving perhaps a little more darkly, I've always wondered why committees are so awful, and I think you've illuminated why here.
Great. I'm glad if I did that.
I'm sorry, I can't see your badge, your name there, and actually I can't read it from this distance anyway. But you know who I'm pointing to.
Yeah. Was there any structure at all to when people were posting their results of their branching? Was there any structure to that, or did everything just kind of filter into the same bulk database that just got randomized on?
Oh, yeah, that's a good question. So, like the real mechanics of how that site is working. Actually, the site is arranged to make it easy for you to kind of browse through different images that have been published. So it's not just some giant bulk thing with thousands of images. Like there's a rating system, so you can give them stars, so you can get the top ranked ones. It ranks them by most branched, so you can have a different view, or you can see what do people prefer to branch from. There's like random, where you can just get something random, or you can even search by a keyword, because people are allowed to label them. So I could say enter face into PickBreeder and get all the faces that have ever been bred. So there's a lot of ways to give people access. And I think that what that also shows is that a successful innovative enterprise needs to give people really good access to all the potential stepping stones. That's kind of a lesson from this. It's like we tend to be very narrow about exposing people to stepping stones. Like if you expose your proposal to a very small panel of scientists or experts, then only they know about this potential stepping stone. But if there's one person out of 1,000 for whom that is the key to their whole life, they're never going to find out about it because they're not exposed. And so somehow, what PickBreeder shows is that there's a lot of value in exposing widely all of the ideas that are out there to as many people as possible, because you just need that one magic connection to go to the next stepping stone.
Okay, I'm going to let Steve ask the last question.
It's just really more of an observation, just that we've seen. We have two examples of this right here at this meeting, right? Yolite started out doing one thing and stumbled upon something else that didn't fully succeed, but it was the thing worth pursuing. Slack famously started out as a game, and they built a tool, and the tool was Slack.
Right, great example, yeah.
All right.
Can I conclude or say something?
I was just going to say, we've enjoyed your talk too much. So much that I will give you a couple minutes to wrap it up.
Okay, I need to think because I didn't get very far. But let me see. I think you all got.
Well, you didn't really have
here.
an objective anyway.
Yeah.
Did you?
So. Well, okay. Let me make this point. We see this kind of phenomenon in several processes. PickBreeder and Novelty Search are artificial, but they have no final objective. In other words, in aggregate, the people on PickBreeder, they're not searching for some ultimate image. That's why it works. Novelty Search isn't searching for some ultimate objective, and that's why it works. Natural evolution, there's no uber organism that the whole process was set out to finally discover. It's not us. That's why natural evolution is discovering all this stuff. If we were the objective, we wouldn't be here. Human innovation, which was raised earlier, like science, doesn't have some uber invention that all of us are walking lockstep towards as we converge in. These are the processes that are most prolifically creative that are known to humankind. And we should be modeling our innovative endeavors more closely with the way that they actually work, which is that they are not objectively driven. These are stepping stone collectors, which means that they're not solutions to particular problems. They're accumulators of potential. The more potential they accumulate, the more potential they can accumulate. And it's that divergence that you see intrinsic in that kind of process that makes it so creative. Let me just say, here's a quote. So from a Chinese philosopher, he said probably better than I could, a good traveler has no fixed plans and is not intent on arriving. And just lastly, I just want to say that, I know this is the end, and unfortunately I'm leaving. I can stick around until about 5 p.m., so I'll just hang around a little bit. But because of that, I have little opportunity to talk to you guys, and but I'd be more than happy to hear any feedback, positive or negative. So please feel more than free to email me at my email address here, and if you want to talk further. Thank you.
Well, that was cool. Thanks for tuning in. Next time I stream, it'll be Friday, 11 Eastern, and yeah, I'll post it in the forum, whatever it is we plan to talk about. So hope to see you then. Thank you.